What is the quantum superposition principle? Have you ever wondered how particles can be in two places at once? This is the essence of the quantum superposition principle. It tells us that a quantum system can exist in multiple states simultaneously until we measure it. Unlike everyday objects, which are either one thing or another, quantum particles like electrons can be in a blend of states at the same time. Imagine a coin that is both heads and tails until you look at it. In the quantum world, this means a particle can be both 0 and 1 at once, or any mix of these states. This is described mathematically using something called probability amplitudes, which are complex numbers that help define the likelihood of each state. At the heart of superposition is the wave function, which represents all possible states of a quantum system, each with a certain probability. When we observe or measure a quantum system, this wave function collapses. The system then randomly settles into one of the possible states. Before we measure it, however, the system exists in all those states together in a strange way that defies our classical understanding. One of the most famous experiments demonstrating this principle is the double-slit experiment. In this experiment, particles like electrons behave like waves, passing through two slits at once and creating an interference pattern. This pattern can only be explained if each particle is in a superposition of going through both slits simultaneously. In quantum mechanics, particles are described by waves of probability rather than fixed positions. These waves can overlap and combine, which is also a form of superposition. This overlapping changes the probabilities of where particles might be found. Think of it like ripples on a pond that combine to form new patterns, but in quantum mechanics, these patterns representing probabilities instead of physical waves. Superposition is also the foundation for quantum computing. In this field, quantum bits, or qubits, use superposition to hold multiple states at once. This allows quantum computers to perform many calculations simultaneously, giving them a potential power that far exceeds that of classical computers, which can only handle one state at a time. The quantum superposition principle is a fascinating example of how nature behaves in ways that challenge our everyday intuition. The idea that something can exist in two contradictory states at once until observed opens the door to bizarre experiments and surprising outcomes. This principle continues to puzzle and intrigue scientists, revealing a world of unexplained physical and cosmic phenomena that we are only beginning to understand.